Everything began back in February, with a post in which I announced our ambitious plans to go to Eastern Siberia to a place called Vladimirovka on the Iya River in Irkutsk Oblast. Last summer we had already explored these areas and made many interesting discoveries, finding traces of ancient insects, fish, and also promising layers where we might find remains of amphibians, pterosaurs, and even dinosaurs. Volunteers were in for 11-hour workdays with no weekends in challenging Siberian weather. Nevertheless, there were daredevils willing to face these trials. And so, we set off again for Vladimirovka, in the foothills of the Sayans. May 15th. Irkutsk greets us with hot weather, 26 degrees Celsius outside, apple and pear trees in bloom. We stock up on everything we need and savor the moment before the intense work days ahead. I stopped by my favorite cafe on Kanadzava Street. Just a small tradition that makes any trip a bit cozier. We drove out to Vladimirovka the next morning, and in just that one day, we went through a dust storm, heavy rain, heat, and cold. By evening, we finally reached Vladimirovka, where they provided us with a 2-room house that even had a banya, sauna, in the yard. On the same day, we settled in so we could get straight to work the next morning. May 17th. With a sense of nostalgia, we returned to our old site. It looked almost exactly as it did a year ago. Now, knowing the fish spots, we began clearing the layers right away. Our first finds appeared by midday. Bayera impressions. May 19th. The harsh Siberian climate didn't take long to remind us of itself. It was around plus 20 degrees Celsius during the day, but dropped to just plus 5 degrees Celsius at night. We spent the nights in an unheated house, which was hellishly cold. You didn't want to poke your nose out of the sleeping bag. Luckily, no one got sick. By the end of the day, we started finding good ginkgo impressions. We tried out different sections, searched for fish spots, and called out for a little frog. May 20th. At first, working felt nice, cool but not cold. After lunch, though, rain began to drizzle, and we headed home. It kept raining the next morning as well, which allowed us to have a leisurely breakfast and work on our abstracts for the upcoming Cretaceous conference. After lunch, we went back to work, but the sky stayed gloomy. May 22nd. It happened. We managed to repeat last year's success. Today, on the 6th day of the expedition, we found fish remains. 2 fish. Enough to see a pattern. A day later, fortune smiled on us again. In a layer of argillite, we found beautifully preserved impressions of aquatic insect larvae. Even the gills were intact. A real rarity. May 27th started off with wonderful weather, but by evening wind and rain swept in. However, that didn't stop us from making another discovery, a magnificent ancient cockroach. The next day, we uncovered the lateral contact of our lens, that is, the boundary of the layer which helps us better understand the geological structure and the history of these deposits. Looking at the cross-section, we could see that the floodplain lake sediments had been eroded. Channel alluvium lay right beside them. And on that same day, we discovered a wonderful dragonfly impression.
Stepan Valerievich will tell us how to record the orientation of bedding.
How to describe the elements of bedding, how to measure them.
Yes, sorry. I'm the one filming, and he's showing us how to describe it.
All right. So we have a plane here. It's not horizontal. We need to describe how much it deviates from horizontal. For that, we use a geological compass. First, which bedding elements do we measure? The dip azimuth, the dip angle, and the strike azimuth.
So far, so good.
All right, the dip azimuth. We place the back edge of the compass on the plane with 0 pointing toward the dip. Here's the 0 point.
And the dip goes where?
Somewhere over there. Next, we level the compass horizontally without lifting the back edge off. That's important. The white arrow shows the dip azimuth. In this case, it's 13.5 to 14 degrees. A 2-degree margin of error is acceptable. Again, it's crucial that the bubble is leveled. Right now, the white arrow on the scale is showing 20 degrees.
Great. Everything's clearly visible. And that little tail, does it align with the dip?
Yes, that's the main thing. The 0 point and that tail show the dip azimuth, the direction of the dip. The dip azimuth is 20 degrees. Next is the strike azimuth, which differs by 90 degrees from the dip azimuth. It can be measured either with the red or the white arrow, since strike can extend in one direction or the opposite. We rotate the compass 90 degrees. Now placing this edge against the plane, we keep the bubble level. In this case, the strike azimuth will be either 110 or 290 degrees. Then there's the dip angle. We use this inner scale from -90 to 90 degrees.
That inner scale, right?
Yes, this one here.
And which bubble shows that?
Yes, the compass has this little lever on the back that controls the weight and needle system that determines the dip angle. We place the compass in the plane's dip direction. We determined it goes roughly this way. Then we center the long bubble in the little tube.
We're finding level.
Yes, leveling it. Then we can safely lift the compass and look. Here's the 0 at the bottom. I'm not sure why there's a 60 and 60 to the left and right, but the 0 tells us the reading. In this case, the dip angle is about 18 degrees. That's it.
The most important question, what do these elements give us? Why did we measure them?
So we can describe how much the plane is inclined relative to horizontal.
Why do we need that? What does it give us?
Right now, it doesn't give us anything.
I see. So if we measure the bedding, the inclined cross bedding, that's when it's useful.
Yes, exactly. In this case, we're just practicing.
Got it now.
Dasha, your task. Please measure this plane. May 29th. While clearing the lens deeper, we successfully brought down large blocks of sandstone with upward flow ripple structures. These features typically form when a flow transports a large amount of material, like during floods. It suddenly turned cold. We started looking at new spots, hoping to find a better concentration of remains. The next morning, the heat was back again. At the new spot, we were finding insect remains quite frequently. May 31st became a special day for our junior research staff member, Iya Vladimirovna. She discovered 2 magnificent specimens of Jurassic fish. June 1st. Summer has arrived. In Siberia, summer is short, and every day counts. Today the temperature dropped again, but that didn't stop us from continuing our work. We found 3 new fish specimens, and insect remains are appearing in whole clusters. We're collecting philopods selectively. We worked at this location for a few weeks, tested the main layers, and uncovered a fairly rich complex of flora with ginkgo leaves and Elatocladus, ancient coniferous plants. We also found layers with insect remains, and even found a small fragment of a fossil fish. Now we're leaving this site and moving farther downstream. Let's see what that brings us.
We need to freshen up.
Andrei Olegovich, this won't do.
I threw away your samples.
Go back there. All right, so we've worked for half a day. The weather's wonderful, and we already have a few interesting finds worth talking about. So right here is a specimen of a Jurassic fish. Most likely this is where its spine ran, or perhaps it's the imprint of the so-called median line, a sensory organ. You can even see the muscle fiber imprints. Right here, they run along this area. On this counter impression, there might be some additional details. You can see the scale imprints. Right here they are. There's also a dark stripe, possibly that same median line. Here's another fish. They're quite small, really. It's possible they fed on the insects that lived here. Or, as has been hypothesized, they might be the young of larger fish that lived in this floodplain lake. Perhaps they were brought in during a flood and ended up trapped here, eventually dying off. We've also got several specimens of insect larvae. In this one, for example, you can see the abdomen, thorax, head, and 6 legs. Everything's in place, just as it should be. Here's another impression. This one with a curved larval body. Next up, we'll be packing everything carefully and studying it further back in the lab. So the collection is gradually growing. It's genuinely interesting material. We'll keep working and searching for new finds. June 4th. We started describing the section below our lens and took samples for paleontological and geochemical analyses. A paleontologist's work is not just about finding remains, but also about understanding them in a historical context, in which environment and under what conditions they lived. That's why we study the cross-section of the enclosing deposits. Right now, we are on the left bank of the Iya River, where we have, in fact, been searching for vertebrate or insect remains and collecting plant remains. Here is what we see. At the base of the section, there is a fairly thick package of sandstones hidden. These are coarse-grained sandstones that formed under channel conditions. In other words, the ancient river carried a large amount of sandy material and deposited it here. We are still in the marginal part of this river valley, where floodplain settings periodically accumulated as well. Right here, in particular, you can see a small floodplain basin that began accumulating like an old channel. into which less and less sand was gradually brought. Only clayey material remained and accumulated here. Eventually, this old channel turned into a swamp, and various plant remains began to accumulate. In other words, the area became marshland. Then the river returned and continued depositing sandstones. The overlying sequence is represented by thin interbeddings of finer-grained rocks, siltstones, alurolites, argillites, with frequent interlayers of coalified, carbonized plant detritus. All of this indicates that we see another abandoned channel here, and some kind of floodplain water body in which relatively fine sediments accumulated. Periodically it became marshy, for example at the end of certain seasons, in autumn for instance, when leaves fell. Leaves dropped onto the surface of this floodplain lake, as we can see in these places, forming fairly continuous strata layers. It is in these layers that we have found plant remains. Leaves of various plants such as ginkgo, chekanovskia, and elatocladus. Periodically, new material was introduced into this lake, most likely during flood seasons. In these layers, we encounter coarser sandy fragments. Sometimes they contain traces of trunks or branches that were carried in by flooding. In the final stage of this floodplain lake's development, very fine sediment was deposited. The interbedding became more frequent, and more plant detritus accumulated. So there was probably some marsh formation here as well. Later, tracing this lens to the right and left, we found a contact where it was partially eroded by the channel that once again approached this floodplain lake. Ultimately, the top of this lens was truncated by a new channel flow, which deposited these channel sandstones with characteristic upward flow ripple marks and cross-stratification. Thus, we observe a certain cyclicity. From here, we will try to relate our findings to this geological setting, and accordingly, reconstruct the environment in which our insects and fish lived, and in which the plants grew. June 5th. Our expedition on the banks of the Iya River is reaching the home stretch. We worked very productively. We found 19 fish specimens and countless insects and phylopods. Only one more day of work remains, and then we'll be heading home. June 7th. The field portion of our expedition has come to an end. Many thanks to all participants. We've done an excellent job. Boxes of plant fossils are heading to Irkutsk, and a box containing insects, phylopods, and fish goes to Tomsk. The sections are described, the layers mapped, and samples taken. Our findings will be part of master's theses, doctoral dissertations, and PhD research. Look for our work in leading international scientific journals.
3D Dinopedia for smart kids and their parents.